जाओ भाई, अच्छे से बैठ जाओ।
Yes. Good evening, ladies and gentlemen. It is my privilege to welcome you all to National Management Day, where we celebrate leadership, innovation, and the future of India's industries. Today's theme, India Tomorrow, Unlocking Industry, Innovation and Talent, perfectly reflects the vision of Dr. Vikram Sarabhai, a pioneer who not only founded ISRO, but also established Ahmedabad Management Association, more easily known and famously known as AMA, with the belief that scientific progress and managerial excellence go hand in hand. We are truly honored to have with us a distinguished personality whose contributions to India's space program have been monumental. Dr. S. Somanath, former chairman of ISRO, a distinguished scientist, and the Vikram Sarabhai, distinguished professor at ISRO. Under his leadership, India witnessed remarkable advancements in space exploration, including the historic Chandrayaan 3 mission, which placed our nation at the forefront of lunar research. His expertise in space technology, launch vehicle systems, and innovation has not only strengthened ISRO's capabilities, but has also inspired generations of scientists, engineers, and young minds to dream big. Dr. Somnath's vision and dedication perfectly align with today's theme, unlocking the potential of industry, innovation, and talent. His journey serves as an inspiration for all of us striving to push boundaries, embrace innovation, and contribute to India's growth. On behalf of Ahmedabad Management Association, it is my honor to welcome and felicitate Dr. Somnath for his invaluable contributions to science, technology, and national progress. May we give a small token? Sir, we express our deepest gratitude and respect for your extraordinary leadership and achievements and hope to get valuable insights from you on today's subject. It is also my pleasure to introduce another eminent leader as the moderator for today's event and who has been instrumental in shaping AMA's success journey, Dr. Savan Godiawala, President, Ahmedabad Management Association. With this, I request Savan Bhai to take over the proceedings and start the conversation for all we are waiting today. Thank you.
Thank you, Rajiv Bhai. And certainly apologies for keeping you waiting for some time, but certainly we all know it is worth the wait for none other than Dr. Somnath. To add to Rajiv Bhai's introduction, day before yesterday, sir, you got the 16th honorary doctorate. So we can imagine. And so many things that he has done and making all of us proud, making India proud on the global level, global front. Sir, you preferred and ideally that this becomes a fireside chat. So we would you can generally communicate some points that you want to, and then I can take over, ask you questions, or you want me to start asking questions, and then we'll open up to the people at large also, the audience also, to ask. So how are you comfortable? You want to give some background before?
Thank you so much. I only want to thank each one of you for having me here to come to AMA and to be in your midst is really an honor. I think there are a lot of pioneers who did wonderful work in creating the management culture, and also the pioneering efforts of AMA is well known. I don't know many faces. Some of them are familiar, some of them are not familiar to me. Want to thank each one of you for being here today. For me, it has been a great journey in ISRO, though I superannuated, but it's not an end of a life. So a lot of things still left to be done. In the sector which I was working in the space sector, it's really an exciting sector. Not just what I did, but all over globally. If you look at, a lot of things are happening in the space sector, and the rapid pace at which it is changing, and the new vision and approaches that are being brought to the sector makes it very lively and worth to watch, and something that we need to emulate and do in India. And this is something which I was so passionate to do. But of course, as a country, that our investments in space sector has been moderate, very low. To start with, when Sarabhai started the whole program, the conviction of doing it was there so much in him, but the conviction on the other side, the government and the funding was not that much forthcoming. And for a nascent nation who doesn't have an industry which is grown to handle complex nature of space technology, it was appropriate to do in a moderate level at that point. But he created a narrative which was important. The narrative was that it is for the people at grassroots level to bring benefit of the high technology to the grassroots level. This connect was made by Sarabhai at that point in time, which was important as a political message to the people, government to allow funding. Otherwise, it would have been cut down, and it was never allowed to happen. For a country, there were questions why we are investing in space technology. But then he was very, very tactful in creating that type of narrative, and he brought a communication satellite from US and then showcased the site experiments of communication and how to connect with people through agriculture related programs, etc. Slowly the funds were coming from government, but in the last 60 years we remain very, very moderate. Though India is still a very leading space power, if you look at the overall investment that we have made in space sector is very, very small, very small. I look at our annual space budget versus our annual budget in space. We get hardly 12,000 crores. 12,000 crore is nothing in terms of the governmental funding that is required for a science and technology program. And is it good enough? Should we continue in this mode forever? And if you continue like this, where will we be in later years? You see our neighbors growing in leaps and bounds. Say, for example, I'll tell you that in India, we have just 53, 54 satellites in space. My neighbor has 500. So these numbers may be the one which will scare you, but it's not for competing with them. We should do something. We should create a case for us to work on, how to scale up. And we decided that it's very important for all of us to understand this and then create a business case for space. Of course, it is very prestigious to work in space. It is good to send a craft to moon and land on the moon. One first country to go and land in orbit around Mars, do some pioneer work. It's all fantastic. I think all of us love that. But ultimately, what for we are doing all of this? Is it for the same story that Sarabhai said, that want to bring the benefit of space technology for the grassroots? Or is it to create an economic activity around which there is huge business, industries, jobs created? Is it for profit that this business must be taken forward? Or is it for strategic reasons this country cannot be left behind compared to my neighbors? You need to identify what for the narratives are to be created today in space sector. This is a crucial issue we discussed in the recent times. We found that it is not possible for governments to create additional investments in space sector substantially. Of course, 12,000 crore is not a huge number. It can be increased to 30,000 crores. It can be increased to 50,000 crore, not beyond that. The budget of America in space sector, the governmental funding is 50 billion US dollars annually, both civilian and strategic. and our investment is 1.8 billion US dollars annually. So it is such a small number. And how do you really scale up? If I get $50 billion, can I do something? I don't know. Okay, we will be cash rich and not able to do anything. There are many challenges in space sector. The challenges involve what are the business cases for which we must create space for? Where is the markets for space to invest and create business cases? Which are the sectors that we must give importance that you become some leaders in some domain? And what are the industrial challenges existing in this country for us to scale up and make launches every week if I have to make a launch? Is it really possible in this country? These questions are the one we addressed, and we have answers. I think there are good answers available, and there are good models we started developing. In fact, I need another 1 hour to give an explanation on what are the thought process that involved in creating this type of long-term vision. And one of the important element of the vision is participation of private entrepreneurs into space sector in a big way, which you have not done. We have not done in the past because we thought that space is such a exclusive club and which is a very secret work which you should keep it with the government. I think this idea has to be removed, and we have done that in the last 2 years. We made it very open and a public message to everyone that it is for private people, industries to participate in space sector and find a business case for it. This is first part. Second is government must also increase investment in space in areas which private will find it difficult to invest. For example, exploration, going to moon, building space station. It's not possible for private investment to come up and put money there. So those are areas, and similarly research and development areas, we must continuously invest to create the enhancing the technology strength. And then slowly this technology strength created out of public funding will move to the private at a later point when there is a profitability and business available. So this transitioning has to happen in next 5 years. Then our contribution to space economy will grow from hardly 2% of the global economy to something like 10% in the global economy. And this is a change which is needed. For that, there are many elements needed: the technology, participation of startups and companies in the space sector, governmental policy that will encourage these changes to happen, creating right type of human capital and training in industries, creating business case for ultimately. Because for whom that we are building rockets and satellites? Elon Musk is building his rockets for launching his own satellites. He has launched 5,000 satellites and he built the Starlink constellation. And everybody criticized him that who will take his satellites? But it was not break even for at least 6-7 years. Now he is making profit after so many years. And he has the capability to take the risk and then build the constellation. And who will take such a risk in India? Which company will build the constellation in this India? We have been talking to many companies. Who has the courage to build a satellite constellation for communication? No one is willing to do it. So there are many challenges of this nature, and government, of course, will not build. No, the government is not the government business to build a communication infrastructure. It is for the private companies to come up and build. So these challenges are in front of us, and with those questions in front of us, let us get into discussion. Okay.
Thank you, sir. We are a management organization, management association, so our questions also come from the point of view of management, and we are happy to see that you mentioned few times that there has to be a business case. Whether it is a research, whether it's a budgetary allocation, or whether it's spending for something to do over a many years' time or over a few period, which will culminate into the final product or not. So the question to you is that with this huge amount of ISRO's involvement in research and then getting into precision, because it cannot be a research where you can take chances end of the research also. What can be that principles which can be applied to transform Indian industries and more from the point of view of making them globally competitive?
There are many elements. One is in terms of industries, it's sector-wise we must analyze. There is not a common solution for industries to become globally competitive. For example, if you look at the software industry, the IT services industry, we have made a mark of our own. Okay, if you look at the pharma industry, generic medicines, we have made a mark of our own. But if you look at the synthesis, the testing of the medicines, and various high-end medicine synthesis and testing and laboratory evaluation, we are not able to move forward because of the legal and many other issues which are involved. So And if you look at space industry, we are at the right time to be competitive in globally. We have the every element for it. You look at automotive industry, we are reasonably there, but then you need to create the next step of doing innovation and upfront research, which is not happening in scale. It is happening here and there. It's not happening in the scale that is needed to go to the next level. EV research, if you look at EV, is also a similar area. There is a lot of scattered work happening, but not in a direction that is very transformative. There are many areas. AI, we started working on quantum. There is a national mission has been announced. It's some area where we can make an impact. 5G, 6G, expansion program, which is again a core technical area we can develop and then create an impact. There are many areas like that where India can work in, and the solution for each of them will differ. So some of them will require academic participation in a very strong way to do the research area. Some of them need scaling investment. That will be the one which will help you to become globally competitive. But ultimately, the whole of the business of the world is run on geopolitics. No, ultimately, and how well we are placed in the global framework will also decide how we are able to do business. For example, India has made a very important decision that you will become a weapon exporter. It's a great decision. No, it's not an easy decision for anyone to make a decision that your defense industry must scale up to a competitive level that our weapons built in India can be sold. It has a moral question to be asked to ourselves. Are you ready to become a weapon exporter and to become financially well off with the sale of weapons? What our conscience will say. And who are the markets for this? The third world countries. And how do you create market for weapons? Now, these are questions which we need to answer for ourselves. So each of them will have different solutions. And I think let us not get into it. That and probably you may be a better equipped to answer these questions who have
Yes.
domain expertise.
Yeah. To create market for weapons, you have to ensure that there are wars happening places.
I didn't say that. I did.
And typically in the management conference rooms, many of the management think that these rooms are war rooms only, where they are strategizing to make war with competitions and not like a win-win. So that's the
Of course.
unfortunate part. But we had a question from our senior past president here, that how did you as an individual, right? That was a question, sustain in these challenges and persevere and still take it for how many years? 38 years you mentioned, right?
It's almost 39, 40 years, yes.
For 40 years in doing all that you achieved. And we have some pictures also where your contribution is there. So what was that that drove you, that pushed you, or that you kept on taking challenges and then kept on growing?
The first thing I must tell you, I had a great passion for the work which I was doing. I loved it. In fact, the 40 years, I never felt it is 40 years. It was yesterday. That's the type of feeling. After joining the organization, it was such a... I had fantastic bosses, people who loved their work, who were able to create the passion in me and fire up that and commit ourselves to do something all the time, irrespective of my personal difficulties or struggles or all that was secondary in front of all of that. And of course, we were able to also create a team, which was very fantastic. The people came from various walks of various social background. They all came. But once they came to ISRO, we have a magic to work on them to create the similar passion. So, we are ultimately a government organization. You know how government organizations are? And it is very difficult to fire or punish anyone. In a government organization, if somebody is not performing, what will you do? If you see, I am not going to work, what you can do at the best? You can make their annual confidential report to be a little bad. He doesn't care. I am not bothered about it. He will still get the salary. And you cannot fire him. And you think about, you are a CEO and you cannot fire anyone under you. How will you get the work output from the rest of the people? It is difficult. In governmental organization, to make them perform is extremely difficult. And this requires only one magic is to keep them inspired to do something. Show them that if you have an idea, that idea can be implemented and you can actually see the fruit of it happening in front of your eyes. And that is a great motivator for everyone. And it is not easy in private companies to see that happen. Very rarely people get that opportunity. But in ISRO, we give opportunity to young people to create ideas, convert that idea into results that you can actually see in front of you. It gives them such a joy, you know. I have enjoyed the joy in my life. I was a rocket designer. When I was the GSLV Mar 3 project director, I was doing most of the design coordination work and also my own designs, which are there part of the rocket. And when I joined the project, the rocket was only a small sketch in front of me. But after 12 years, the rocket became massive rocket, 630 tons in mass. And I was the project director, responsible to clear the rocket for launch. And just imagine taking off. No, when I saw a baby, no, you like your child taking birth and it growing to become a great personality. You feel so proud. No, where will you get that? For what money you can get that joy? And this is what kept us going and take new challenges and new tasks all the time. Later I had the fortune to develop the SSLV, the test vehicle, the Gaganyaan program, and all that new programs that are recently announced, the space station program, Chandrayaan 4 and 5 program, Venus orbital mission, NGLV, the new rocket which we are developing. All of this architecture, I was very happy to work with young people. The NGLV rocket which we are now announced, some of you may be knowing about it. I talked to some of my young people who just joined few years. I told them, you must learn how to design rocket. I will work with you. I was the director of LPSC at that time. I told them how to design this rocket. They don't said, I don't know how to do this. I said, you will learn. You will work with me. They were not responsible for design a rocket. They were doing something else. I told you, collect some 10 people. We will discuss how to design rocket. I made them to develop it. The whole new idea came. And later it was brought to the attention of the senior people in that. And then we culminated into a full development history. So today I can get you, even after retirement, they won't leave me. They will ask this question, that question. Now it's owned by them, not by me. But they are inspired to do that work. They see their ideas are in the rocket now. So this is the beauty of it. No, that's the one which keeps us on fire.
No, but I think these are the real management challenges and real management lessons. That passion and then the innovation and the ideas converting into passion. Otherwise, in the background of a government setup is not easy. One thing that the industries always have to do is as a basis of the business is risk taking. Now risk taking, that industry, they calculate, and but at ISRO level, your level of risk taking and the stakes are so high. So how would you see the industries, that how do they embrace that failure? Because failures are, according to me, it would be a routine thing at ISRO before you get into a big success. So what would be your advice to the industries on the failure and risk taking abilities?
Unfortunately, the Indian mindset is still not accepting failure as a possibility. This is an issue. Managerial side also, we will see this. We don't like projects to fail. We don't. I like a new companies coming up and ultimately failing. Many of the companies starting may not actually finally reach a successful conclusion. If you look at the West or in US, you will see companies come up, they succeed, many fail. The next day, he start another company. But if you look at an Indian context, this is not true. Many of them, once you fail, coming up again, back to again is hugely difficult because banks are there. Your credit rating goes down. You will not get further loans. You know it. So, when you look at ISRO is also is not different from it. If you fail anything, it's a black mark for you. The government looks not kindly with you. No, your failures are not treated that with you respectfully. So handling failure is a very difficult thing. And especially when money is very large, because every launch cost failure will cost you hundreds of crores, thousands of crores. So the failure can be extremely costly. But you have to also understand this sector is like this. Failure is a possibility, very high possibility. It is because of a simple reason that you cannot test everything before you actually fly. Even if you design a fighter jets, the Tejas and the light compact aircraft, before it actually does a full flight, how many hundreds of flights it would have done, rolling on the tarmac, flying at low speeds, testing here and there. Finally, it takes off one day with the pilot properly. Think about a rocket which I designed, LVM-3, the very first launch. I had no opportunity before that to test in that condition. No opportunity. The very first flight that it takes off has to succeed. There is no option. and you say it should succeed. What is that? What is that you are telling? So thousands of parameters, complex systems, everything has to work. Every connector, cable, software, skis, algorithm must work. And this is the difficult part of it. And people still not understood that this is such a mission, such an area. Chandrayaan 2, you said that ISRO failed to land. But we have never gone to Chandrayaan before. No, we have never gone to moon and tried to land before. This is the first time I have gone. I have no experience of going there and landing even on Earth, for example. We are not able to do this. And you are expecting us to succeed in the very first attempt. And unfortunately, this is the beauty, this is a risk, and that's why it is exciting. And for that, you need to put all our minds together. And failures are very difficult things. I have gone through at least some of the failures. I have seen the first failure of PSLV. I have seen the failure of GSLV, at least 2 failure analysis committees. I was there. I have, when I designed my SSLV, the small satellite launch vehicle, the first mission was a failure. Chandrayaan 2 failure. And many failures taught us how to handle failures. It requires, we become more active when it fails. And we learned much of the tricks of the trade only through failure. Success many times don't tell you the secrets which are there. I still remember when I was a young engineer of PSLV project, the ASLV was failing. 2 launches failed. And the ferocious activity which was taking place in that time to understand how rockets fly. And we realized that most of us in ISRO don't understand how rockets really fly. There were a lot of gaps in our knowledge. And this came out very evidently through failure. And we learned it. And nobody was coming to teach us. NASA, ESA, nobody will come to teach you. It will be learned in a hard way. And that's the beauty of it. And we were very successful that we were very resilient to understand failures and make corrections. And it's only because of the personalities involved at that point in time we were able to handle this.
So they say failure is not a person, failure is an event. Yeah. And then the gentleman fails 10,000 times to invent an electric bulb. So that's, if we call it a failure, he would have not done the second time or more. But on the budget part that you mentioned, that US would have $50 billion versus India, which would be a fraction of it, and 50 billion would be some 4.5 lakh crore in the Indian rupee terms. But from the point of view of cost, because this is a big news that when you launch, and if I mistake not, Chandrayaan, and then it was at a fraction of cost of other countries, their satellites being launched. That how did you, because it has to have a out-of-box thinking. If you were copied, or you would have gone on the technology where NASA's are going to be launching the vehicles, then it would certainly be that. So how did that happen? What was that, I would say, intelligence that you could get, or the intellects that you could get in thinking out of the box? And what could be that the present management could be learning out of it?
No, first I must tell you, the cost cannot come down drastically because of the material that are involved in building this are the same. No, aluminum. It costs you per kilogram cost in India or in US, more or less the same. Only the exchange rates difference. Steel, electronic parts. Actually, they will be costlier in India than in US. Let me tell you, because aluminum for building the rockets are coming from Europe. Electronic parts, chips are not made in India. It's actually imported. And the steel, of course, is made in India. But many of the items are actually coming from outside, and there is no way they can be made cheaper than that you can do in US or Europe. Then what is the magic, you will ask? The whole magic is in terms of the various components that actually peripherally available to build a system. For example, one of the principles is that while you are actually doing costing, because I had done a lot of costing work in my projects, reports writing. In fact, LVM3's project report was written by me. I was a member secretary of the committee, how to write the costing. So when you do the costing, we have been trained internally to look at the frugal way of doing it. First, you must make your mind that you are going to do it at a lowest cost. If you know how you are going to jack up the cost, those who are written project reports, you know very well how to jack up the cost. You know the trick, no? So you can also do the other way, how to bring down the cost by appropriate managerial interventions. So what are the managerial interventions? One, finding out how to do, what is approach to realize a product. There is something called developmental cost. No, anything requires a developmental cost. There is an operational cost. So our attempt is always in bringing down the developmental cost and cannot optimize the operational cost. That means the unit cost of the rocket cannot be brought down drastically, but you can always bring down the cost of development. So that involves models, standard models, your engineering model, proto model, qualification model, numbers can be reduced. You can give more thrust on simulations and analysis and less on actual hardware testing. You can also recycle hardwares. So we principle we follow in ISRO is that everything is reused. So the waste is not there. No, even if I make something, I will, after test is over, I will model, recorrect it and use it for something. So reuse the model, so you recover the cost. Also, there is another great secret I will tell you is our industries. Indian industries are so passionate to work for ISRO. And whenever I approach an industry in India, they are very happy to take on the work. And they don't worry about profitability too much. Of course, they are not making loss. They are running at a profit when you give a contract. To many big firms do our contractual work. And all of them gain because of we work with ISRO. Their skill sets improve. Their quality of work improves, and they are able to capture other markets because they are working with ISRO. The electronic products, the materials, the manufacturing, every domain, I find industries scaling up their skills because they work with ISRO. And they do it at substantially low cost. But don't tell that this is outside, they will come and change it. But this is also a magic through such approaches that we are able to control the cost. And finally, India is one of the best place for manufacturing to be done at substantially low cost. This is truth. Compared to global standards, you are able to do high-end manufacturing at substantially low cost because the investments, the productivity is much higher than that you are able to do other places. And these are the secrets.
But the cost of travel that after launching, that was absolutely a fraction, if I mistake not, right?
No, that's a way of narrative, no? For example, so it involves the cost of the rocket, it involves the cost of the satellite, and involves all the cost of development. So all of the costs put together, and in fact, we have spent only that much. Okay, we are not spent too much money. I'll give an example. Possibly you will understand. We are recently developing a satellite called NASA ISRO Synthetic Aperture Radar. NISR, it's called. And this one part of the payload is developed by USA. NASA JPL is developing that. And another half of the payload is done by India. And the main bus of the satellite is done by India, and we are going to launch. But the satellite, I understand, India has spent X amount of money for the satellite mission. The money spent by US is 5 times that. For the same satellite, for the same share of work, their expenditure is 5 times. I don't know what is happening in US really. I know I can do it in X cost.
We hope US guys don't come and take him, kidnap him to NASA. Okay. So, sir, we see a lot of private sector companies now getting into launching this, like SpaceX small satellites. So how do you see that growth happening in the industry, whether it will be possible, feasible for the Indian private sector also to get into the space sector?
Definitely possible. Definitely possible. That's why there are some startup companies like the Aknikul and Skyroot has come up now. Their goal is to develop rockets which will be capable of launching 100 to 500 kilogram class of small satellites. So they are developing a solid rocket-based rocket which is done by Skyroot, and a semi-cryogenic based rocket which is done by Aknikul Cosmos. So both of them are targeting this niche market of launching small satellites. But then there are other bigger concepts, and other people are also coming up in companies in India to come up. But then I will tell you, the market development is another issue. The small satellite market is not that huge to create a very impactful business case today. We need to work on it. How to create a large market for small satellites. A lot of them are being built, like Earth observation constellation, debris monitoring constellation, communication IoT services constellation. These are being built now. But then this will also become saturated after some time. Rocket business is like that. If you make a rocket, it has to survive for next 10, 15 years, because next 2 years only business case, it's not worth developing it. So how to create a business case for which will sustain for next 15 years is a huge challenge. And this is where I said the market development is a major challenge. And we need to look at within the country where space applications have still not penetrated, and how to create new satellite demand there, or how to create it outside the country. Maybe working for Southeast Asian countries, our East Asian countries, or Africa, South America. There are still countries which are aspiring to become space. We need to go there and then create markets for whatever work we are doing. Otherwise, this business cases will not survive successfully with the profitability. This is a major issue.
Another question is the founder, Dr. Vikram Sarabhai. He founded ISRO. He founded Ahmedabad Management Association, and we always, feel very happy when we have this communication. This happens. Now, how do you see his vision, so far as it influences the science and management in the industries or anywhere today? Because you've seen very closely how it is the culture that is created at ISRO also, and you have a little flavor of AMA. But apart from it, it's more about Dr. Sarabhai's vision.
No, I had no fortune to see him or come in contact with Sarabhai. By the time I joined ISRO, he was no more. But then his legacy lives in the organization. No, many a times, every time we participate, we hear some stories of Sarabhai, some way or the other, by the seniors who used to speak about it. I will share you some glimpses of it. So Sarabhai used to come to Trivandrum, where I worked. So he comes every month. His coming to Trivandrum was considered as a celebration. Sarabhai comes in his jubba and kurta and chapel. He will come and then he will go every lab, and every engineer is interested to showcase something to him. That time when Sarabhai was there was no rocket program. There was no satellite program. He was just started the space program, and every lab was developing some technology or the other. There was no satellite to be built, no rocket to be built. So they will come up with some idea. He will do this testing. He will congratulate everyone. He'll go, and morning till whole night he'll go around the laboratory and then see this and encourage everyone to work on new things. One of the important quality he developed at that time, possibly Sarabhai was successful in bringing at least 20 people from US and Europe who were leading in this area. Influenced them. They were top scientists or working in many laboratories. He told them to come back to India and work in very difficult environment back in India. On the sheds and places they worked, they contributed to develop that knowledge that we have today. And he was inspiring them to come back to India and work. And that leadership was also fantastic, that he was creating a non-hierarchical management structure, which we follow even today. That though I am chairman, I will speak to young people freely. They have an access to me. We don't stop that type of only senior people only will talk or nothing like that. We go to the same canteen and take food. Okay, we deal with people at equal level across the hierarchy. You can in review forum in review forum, you suppose a chairman is sitting and a young fellow is there who happen to come and see, he can still ask a question and I am bound to answer him. If you think that he deserves an answer, I can ridicule him. And we create such an open discussion forum. Possibly some people follow, some people may not follow, but actually we created such a very conducive environment you can actually learn and grow. And this is what Sarabhai created there. Legacy of Sarabhai is primarily in creating a leadership, open system, transparent interactions, all of this. But then I will also say, when you speak about Sarabhai, after Sarabhai's demise, there is another leader which is very important, is Satish Dhawan. And Satish Dhawan also changed the whole nature of the work of ISRO and converted this random wax of R&D into projects. I think management people understand projects. So the concept of projects came only when Satish Dhawan came. The initial years were all random walks. Sarabhai was so keen to develop technology here and there, but he was not giving a direction. Do a SLV3, do an IRS satellite. That was not there at that time. When Satish Dhawan came and he said, now time has come for us to identify a project. Then came SLV3 and Kalam. Then came UR Rao and the satellite, Bhaskara, Aryabhatta and all that came at that time. And that gave all these random walks now focus to create that two launch vehicle and satellites. So these two fellows like Sarabhai and Satish Dhawan created that initial, that overall architecture, all of this, which is now taken forward. Every chairman is aware of it, taught about it, and we try to imbibe as much as we can.
Wonderful. when it comes to AMA also, every time we use this word, there's a legacy, and that legacy which continues with so many past presidents, so many leaders that we have got also at AMA, and certainly at ISRO. It's a huge amount of responsibility more than anything else. So one last question I will ask, and of course I have more questions, but then we'll open to people also, audience also, to ask questions. We can have the microphones if you want to circulate that. But what is one innovation in ISRO's history that was initially met with skepticism, but later turned out to be a game changer, that you would like to narrate?
Definitely cryogenics. Okay. Uh, because I am coming from that area, there are other things, but I will limit to this because you asked me only one. Say,
Maybe two or three also.
say cryogenic technology was so impactful, but then it was treated with skepticism. When we started building rockets, SLV-3, that time cryogenic technology also started. I know that in our lab in Trivandrum, liquid gaseous hydrogen oxygen engine was fired in 1970s. That was a time when solid motors were also, solid propellant based rockets were also fired. And that was a time when Russians are also firing this type of engines, cryogenic engines. India was also firing in India. But then unfortunately, entire community in ISRO was very skeptical about our ability to handle hydrogen and oxygen and make an engine. Very skeptical. And everybody said, we have not even fired a solid rocket properly. You are talking about cryogenics. And nobody allowed the team who was working on cryogenics to proceed. For next 20 years, they were not allowed to work on cryogenics. Just imagine this. And later, after developing SLV-3, ASLV, PSLV, we went to Russia and borrowed that cryogenic engine to us. But then it took another 20 years for us to develop the cryogenic technology later. Now GSLV came, the cryogenic technology. So these are the things which will happen in history. You can grossly underestimate our own ability sometimes. So somebody who will initiate and do things, possibly people can say, oh, this is all not going to happen. One thing which I tell people is never ever say this is not possible. Okay. Because you may be making a gross mistake.
I am possible, not an impossible. Yeah, Sunil bhai.
Another important thing
Yeah.
actually I must tell you is about our imaging. Before the digital cameras came, the CCD based detectors, the charge coupled devices based detectors for imaging making were first done in India. Even before the world did a good remote sensing camera to do imaging of Earth, Indian in SAC Ahmedabad Physical Research Laboratory developed that first type of remote sensing capability. Pishardi came and then did, and many others who are leaders here did those instruments and the detectors development. And we were the world leaders in imaging technology from satellite. Somehow that also a preeminence of doing it didn't sustain. It actually went down, and now slowly it is coming back. So again, one of the innovations that we did is similar to propulsion, cryogenic. This is one area which we did not kept our leadership very strong over the years.
So two very quick questions. Government has got many labs, many programs, and many institutions like ISRO. But ISRO is a cut above many others in terms of reaching global excellence. The standards are high. We are the fourth country in the world to do many of the things, and the first one in many other respects. So when you look and you reflect back, what is that one thing that helped ISRO to become global world class over the number of years versus so many other labs and so many other programs that are running in India who have not made a name, have not made any international impact? And the second corollary to this question, sir, is what is the next field? What is the next future in space technology over the next 20, 30 years?
To answer your first question, I must tell you, I am only in ISRO and I was not in any other lab. So I will not be in a position to speak why others are not performing. Or rather, they are not performing is also not right, in my opinion. Possibly you are not exposed to their contributions. I will only say, I have an experience with some of the CSIR laboratories. Fantastic work they are doing. And possibly, I will only say you, possibly ISRO is more vocal in or visible in terms of their work that you are doing. Rockets, when you launch, you can actually see them. Satellites launching, they see them. But CSIR labs, which are running across the country, there are 30, 40 labs doing fantastic research and front-end research in many domains. I will also tell you the defense research and about DRDOs, the missile program where Abdul Kalam had led, actually produced one of the finest of the missiles that India has ever produced. The Agni series, the Prithvi, the Nag, and many, many others. There are problems that we faced, like the development of transport aircraft. India was successful never in making a transport aircraft or a fighter aircraft of a significant magnitude. Or we were not able to make an aircraft engine of a significant, though we have made cryogenic engines and big engines, we were not able to make a aircraft engine. It has its own challenges. And there are many, many, for example, we never ventured successfully into making high-end computational chips. Electronics revolution has not happened. Though originally there was the CDAT and many other laboratories were established, but it didn't taken forward to develop leading electronics development. It all goes with some of the management aspect of it, the leadership issues which are associated with that, and typical government problems that can happen if the original vision of its founders were not established in the organization for long years. This is a very important issue. But I can tell you that it's not ISRO alone. I think many of the public sector undertakings have done fantastically well. Look at the railways. No, you see railways is an inferior organization? I don't think so. Railway is one of the finest of the engineering organization of this country. The type of expansion programs and it's happened in this. You look at the telecom sector, what is really fantastic today? Today we have a mobile connectivity which is the best in the world and the cheapest in the world. No, I will tell you that. Look at the agriculture. We were 35 crore people once and we were starving at that time. And today we are 140 crore people. Are we starving today? No. Why? Where is the magic going on? How the agriculture has grown to a level that we are being supported, 140 crore people. So fantastic things are happening in this country. Look at the road network that we have developed. So I will tell you, public sector and government is working fantastically very well. Of course, there are deficiencies here and there, but that is not an important issue. I'm very happy that ISRO is able to be showcased as a successful thing. I want everyone, every PSUs and places where they have done well, let them showcase. I think India is a very powerful country to do things. No, let us not be ashamed of anything.
Second part of the question, the frontiers of technology.
Yeah, in the space domain, what is going to happen in the future? There are many things. Actually, there's a long list I have, but shortage of time, I will not tell you. But I am very sure the future of the space will be in terms of providing immediately direct mobile connectivity to you. Today, you are looking at mobile and the towers are there, which will give you connectivity. The streaming of internet at very high speeds will come from space, which is going to happen in next 3 years, 4 years of time. Earth observation and remote sensing, signal intelligence is going to be very, very powerful. Everything that happening on Earth will be watched from space at very high resolution, including you are walking, where you are going, all that will be watched. Your telephone calls will be tapped. Your signal will be taken unless you encrypt it with quantum. Okay. and it's growing and people will go to moon and Mars and colonize. Not many far years from now. And rockets will be taken, used for moving people from one continent to another, not aircrafts. Because today you take 16 hours of flight from America to Australia. It will be over in 30 minutes. And rockets will be available for you to travel like that. And that you will go, instead of going to airport, you will go to rocket station and take a flight to go.
Yes, Yatindra Bhai.
Yeah, I think one of the most inspiring moment for all countrymen was launch of Chandrayaan, and at that point of time, the way in which you are introducing your teammates to the Prime Minister, and also one of the notable aspect was that you are back with woman power in a big way in your team. So could you please mention that how you could create that kind of team, and particularly women, because today the Western world is talking about gender diversity, but I think it should be gender unity in terms of cohesively working together. That is first question. The second question is about the latest complex situation which is going on with NASA space mission, where the astronauts are stuck in the space, and SpaceX is going to take their rocket over there and bring them back. How sure it is going to happen?
On the first question, introducing my teammates, it's my responsibilities, no, to introduce my teammates, and because of them that I was able to do these missions, and it's my moral responsibility to recognize their contribution, and everywhere I do, I think they have been standing with this, including seniors and juniors. But unfortunately, I cannot introduce all of them. Very limited number of people who were there to at that point in time I could introduce, and hats off to them for their hard work. And on the women's side, it's not my contribution. I think we have a culture in the organization to recruit women. Have you ever seen ISRO's advertisement? We say we give preference to women in recruitment. We write it boldly. We encourage them to apply. We encourage them to join. And slowly, the number of women scientists in ISRO is increasing. The recent recruitments I can see, women percentages are much higher than 30%. This is growing because of the more people are taking up science and engineering, especially from ladies, and they are interested to join ISRO, and that's a very positive thing. Because of that, today we have at least 20% representation of scientists in ISRO, and maybe 23, 24 overall, including administrative and others. It's really a positive thing to happen, and the type of work which they are not routine. They are actually doing very core work. Some of you may be knowing they are project directors. Some of them are the real coding algorithm people. Some of them are the core designers of them. So not a supportive role at all. They are doing the core responsibility. And it's very important to showcase this to the whole of the country, to show there are a lot of women working in space sector. I think it's a very great thing to happen. Now, coming to your last question of Sunitha Williams coming back, definitely she will come back. I can only tell you, she went as an astronaut for testing one spacecraft, the Boeing Starliner, which was the first time launched by Boeing rocket to test its for human spaceflight capability. Unfortunately, that had a problem, and it has to return back without them. Now they are going to come back in another company's Crew Dragon SpaceX craft coming back. You can understand when two companies are competitive for doing this, there will be some issue. It could be a commercial rivalry. It could be a technical incompatibility. For example, the Sunitha Williams was trained in Boeing Starliner, not in Crew Dragon. So their suit, which she has, is not a Crew Dragon suit. It's a Boeing Starliner suit. And her interaction with the machine, he wouldn't have been trained to handle in Crew Dragon, which is not the regular flight for her. So these type of things will take time for them to understand and solve technical issues, train them to appropriately, negotiate with these two companies to arrive at the cost involved in bringing them back. The cost will be too high. I know the cost is typically $300 million. So they need to negotiate and fix the price, fix a slot, all of them. So all of these are going on, and we are unnecessarily making a news out of all of this. They know how to solve the problem. It is their problem. Okay.
Please.
Namaste, sir.
Namaste.
So when we talk about India tomorrow and unlocking innovation, I want to ask a question about children. So when to nurture their curiosity or scientific aptitude and attitude, one thing we see is exposure. So we try to give that. What other things you suggest to enhance that?
To increase the scientific curiosity?
Yes, sir.
Okay. The first and foremost is to create an ambience in whichever way you have. For example, are you working in which place?
Sir, I have my own endeavor, initiative called Sinotech.
Okay. So in schools and colleges, you need to create an ambience which will actually don't promote mugging up, asking
Absolutely,
questions. No, inquisitive nature. For example, small stories related to our universe itself enough to create that inquisitive and interest. So create that nature of questioning and nature of discovery, which is the modern way of teaching and learning, not mugging up.
Yes.
So second is allow them to experiment. Make their hands dirty. Many a times this is also not happening. Experimenting, trying to find out, This is also nature of the new learning processes which is involved. Thirdly, allow people to go and experience things which are different, because the world is so fantastic. For example, looking at lectures of great scientists, you can
Yes.
actually YouTube and many others. There are
Yes, sir.
possibilities
To
today.
answer this, I think I can answer that we thank AMA for allowing them to hear you,
Oh, there
and
are
it's
many.
absolute
We
pleasure,
have, we
sir.
have few
Thank
kids
you.
over here.
Thank you
sir.
so much.
Because I got inspired by such things. I read
Absolutely.
some books, I heard some people, and that's through that I created my interest and enthusiasm in this.
True.
So everyone can really happen, and your career deciding periods make them exposed to these type of things.
Thank you so much.
Thank you.
They should start learning about rockets because they are going to travel in rockets, not the planes. We'll have two more questions, last two questions. Yes, the lady in the center.
Good evening, sir. My name is Vishwa. Thank you so much for giving me the mic. I have two questions and one thing that I would love to share. You had a great story of 40 years and all the teamwork you did. You inspired them, the government organization, and everything. So we have our Tanmay sir, who has the same story of 40 years trying to teach astronomy, and we have made the studio that sir talked about at Bharat Circle. But we wish that in upcoming 5-10 years, all the students of Ahmedabad will be at ISRO, and in ISRO, the culture will be of fafda and jalebi. So that is our aim, that we do that. We bring Ahmedabad to a whole another level of astronomy, because we are business people also. That's why. And I have two questions, sir. One is that when Chandrayaan 3 landed, that one thing that was the success that we wanted to do was that Chandrayaan 2 failed, so we wished ki it lands. But we never, ISRO never declared about the HOP thing, about bringing back the module, which was for Chandrayaan 4 and 5 sample back. So why didn't we, market that thing also? Why did we keep it a surprise?
My dear, I never planned those two things.
Oh, wow, amazing.
See, all those came as a later idea. It landed, and I was there in the control center. Our landing happened. The rover door opened. The rover came out. There were some initial hiccups. It came out, and we were able to move it around 100 meters. And we are doing the experiments, and all data has been collected. And then another 2 more days to go before the dawn comes, the night comes. Okay, we were happy with all the result, etc. And we found that there is enough fuel left in the Chandrayaan lander. And what more we can do? I was going around and talking to people. What we can do now? Now we have accomplished all our goals of the Chandrayaan 3. And what more you can do? I discussed, why don't you restart the engine and go to another location? I asked them. Immediate reaction was no. How to, because it is already deployed. I had to fold it back, and then ensure that it will fall back. If it doesn't fall back, the whole again it goes bad. So everybody was a little skeptical. Why should we do? Then I said, nothing doing. I think we have 2 more days to go. You must find out a solution. So immediately my team sat down. They have to write a new code, new software, because it is not there in the software and the whole thing. Restarting and going from there. It is not written there. So they wrote immediately another code. They put it in our simulator. We have a ground equivalent system, and tried out whether it will work. The valves have to open. It has to generate thrust. It has to control system has to work in the transient. There are so many technical issues which I will not discuss with you. And they simulated and seen that it will work. Then I said, why don't it go some 30-40 meters away? Then immediate reaction is, no, sir, it will topple. Then if it topples, it will be a bad name for us. I think, what bad name? Let it topple. What is the problem? Then I said, then again, lot of objections. Finally, I persuaded the fire for short time. So they let it go up and then come down. That much I did.
Amazing.
Okay.
And
Then
even-
one more thing, that bringing back that other one, same thing happened. Chandrayaan 3 program, the night has come and this is still rotating around sun. Then I asked, what is going to do there? I asked them. It has done its job of communication with the lander. Lander is already dead. Now we found that it is not going to work any longer. The night was over and we found it is not waking up. Then the orbiter has no job to do. So why you leave it in moon? Let us come back to Earth. Anyway, we have to bring back to Earth. So what technique we will play? Then again, my team was sat together, software, computer simulation, everything. Then we got it back by some thruster firing. So these were innovation of trying out do something differently after it was never planned. So it was not a secret.
Wow, great, sir. Thank you. Thank you so much, sir. Sir, one more question. Sorry.
Quick and crisp.
Quick, short. Sir, we developed a new website of ISRO, I guess, few years back. So if we compare the website with NASA, why we have a great team of engineers, computer engineers in India, IT engineers itself, why our website is not that interactive for us that way? Because Gen Z people love that. The websites, the apps, and everything. We can attract them through that. That's why.
I fully agree with you. I will convey this once again. When I was there, I tried to make a lot of improvements, but I understand you are not happy with it. Please bear with me.
Thank you so much, sir.
And these are the target, this any young guys over here have a question, I would like them to ask, because maybe some advice to them. These are our future scientists, hopefully.
Namaste, sir. We both, oh, sorry. We both are a part of our college's rocketry team. And as we joined the teams, we expected to do a lot of research and development. But we were faced with many logistical problems in terms of team management and keeping the members around 8 to 20 members inspired. They are all passionate about what we do. We do rocketry basically. And so how, as you are a leader, can you share some experience to scale down from ISRO to our little team? So what we can do to
And also, sir, like how to design the project. We were discussing about how to segregate the work 2 days back, and this was a very difficult job. That how to segregate. We are just 8 to 20 people.
Fantastic thing. I will be very interested to work with you.
We will also be interested, sir.
So what we will do is, no, these are things which I cannot share with everyone else. Huh? I will share with you.
Okay.
Because you two people are there, I need to speak each one of you separately. I need to understand you. No, the message I need to give each one of you will differ based on your ability. That I need to gauge. Okay. Because just now you spoke, I will happily connect with you through a video meeting. So if you can, some email, etc. My email ID you can note, but
Yes,
I won't
sir.
tell everyone. Otherwise, they'll start
Now
sending. So we will connect over some video meeting and then discuss how to handle this. What are the challenges in team building? And I can only tell you one secret. 20 people is a nice team, but responsibility has to be taken by one or two. Ultimately, things will be done sometimes only by one. And he is the one who will drive those 20 and never show that I am driving. You understood that?
Yes, sir.
It is very difficult. Okay. And that requires some people skills, how to drive the 20 people crazy, but at the same time remain very cool and do a lot of work yourself. You need to dedicate yourself to it. Otherwise, it will not move. And every success story is out of passion of one person. One person, really. Not really 20 people or 200 people. And are you passionate personally?
Yes, sir.
Then it will happen. Doesn't worry about those 20 people.
All the 20 have to be passionate and not worry about the other 20 people. Maybe we have 10 more minutes, so don't worry. We'll take 2, 3, 4.
Thank you so
questions.
much, sir.
Yeah. Yes, somebody. Yeah, we'll have. You can give it to anybody. Of course, the youngsters are always a preference.
Hello, sir. My name is Jaitra Patel. Actually, my question is, I envision myself to be the ISRO scientist one day. So, sir, what should I keep in my mind and should never forget to be the ISRO scientist? What should be my goal?
Okay, you want to be an ISRO scientist. That's all?
Yes.
It's such a very basic goal. It's not enough. I will tell you that you must set a still higher goal.
Sure, sir.
What is the higher goal? Think about it. ISRO scientist is such an easy thing.
Chairman of ISRO. The highest of the goal.
Yes, sir.
So, if you are to become an ISRO scientist, very easy. You study some good subject, you write the examination, you pass, you become ISRO scientist. Very simple.
So, sir, if I want to be the chairman of ISRO, like you were,
Now, for that, you have to first become ISRO scientist.
sure. Thank you, sir.
Okay.
नमस्कार सर, माई सेल्फ डॉक्टर शिवांगी खानवाला, आई एम प्रोफेसर. सर, सबसे पहले तो आपको बहुत सारा कॉन्ग्रेचुलेशन विश करना है, बिकॉज यू आर अ रियल हीरो ऑफ अवर इंडिया. आपको नहीं पता, जब लॉन्च हो रहा था ना सर, हम सब किचन में, ऑफिस में, रोड पे, जहाँ पे भी थे, सबने अपना अपना मोबाइल खोल रखा था, एंड वी ऑल लाइक क्रॉस द फिंगर्स. 10, 9, 8, 7, that was something else. Thank you very much, sir. Thank you very much to be proud of our India. और सर, एक चीज़ आपसे पूछनी थी, जब भी आप अपनी टीम सिलेक्ट करते हैं, ऑफ कोर्स नॉलेजेबल पर्सन इज देयर, नॉलेज क्राइटेरिया तो होता है, उसके अलावा क्या क्वालिटीज़ है जो आप सिलेक्ट करते हो अपनी टीम के मेंबर्स में? और जब भी जो क्रॉस फिंगर वाली मूवमेंट्स होती है, तो आपका प्रेशर आप कैसे मेंटेन करते हो सर? आपको रात को नींद आ जाती है?
The funniest part is I had no much choice of selecting the team. See, I told you, we are in a government service, and I didn't select any of my team. They are the one who are already there. So, how to make ordinary people extraordinary? You think that there are some exceptional people by birth? No, nothing like that. Everyone is very competent and capable. Only thing is you need to understand what is their strength and act accordingly. This is precisely what I told him also. You need to measure him. And everybody cannot measure. Some people only have an ability to measure people. No, you need to be an extremely good in observing people and understanding what their strengths are. And then put them appropriately. Give them responsibility appropriately. And then you can expect wonderful things from them. And you give them something which they don't like, they are not competent, they are not capable, and expect them to wonderful things. It will not happen. So within the team that you can access, of course, you will select certain people, but you will always assess people based on their competence levels in different areas. Some are good at in technically going deeper and critical things. They will always be very critical, and they will like the way you do. They are also important. They give you a feedback which is never will not come from people who will praise you. Many a times I like people who are actually critical of me. No, they will give you the insight which you will never have. There are people who are good at giving suggestions and solutions under extreme conditions. They only have the patience. Some people have great patience. Some are movers. They will push things and get things done, but they don't have patience to go into finer details. You need many characters. It's not technology knowledge that is important. There are very characteristics of people you need to put at very, very places. And this is very important lesson Abdul Kalam has taught us. When he was SLV3 project director, I have studied from my people who has worked with him. They tell how he select people, how they put them people, how do you mentor them, how do you extract them, understand their language, their region, their taste. No, each are important. In team building, each of these are important. And you need to know personally people. And if you do not know, you cannot get guessed out of them. That's why team building is a very art. No, you put 10 people, you will not be able to do anything. You need to understand them and put them appropriately. And this is a very, very something which you will learn only in ground level. Okay.
Maybe we take one more question. Yes, please.
Thank you so much. Good afternoon, sir. This is Apurv Jha, and the question that I have for you as a management student is, what is the research process like for a space mission? Like for Chandrayaan 3, how was the research done? What was the data gathered and what frameworks were used by your team? Can you share a bit about that with us?
A lot of things. I think again, based on the time, I think before we take up any missions like this, Chandrayaan, we convene a committee meeting or called scientists who actually are moon scientists. And they will ask them what are the pertinent questions that are important that need to be answered in a mission like if you go to moon, what exactly are the questions that you want to answer? So we list hundreds of questions, important scientific topics. We say with the global research happening on it. Then we will identify which all areas where we can contribute and what are the skills available in our scientific community. Next, how to convert these questions into instruments that can actually do measurements. Then we identify strengths of such instruments, whether there is skill available within the organization to develop and make them. Then candidate instruments are sorted out. From that, shortlisting is done. And then we check whether technology is available to build them within this country using sensors or designs. Then finally, some of them are built and qualified and used. Then a mission is planned. And once this data comes, these principal investigators of these instruments will get all the data. And they will make these measurements based on this, they will make science out of it. So I will tell you in Chandrayaan 3, we have put 5 instruments. 2 of them are related to mineralogy. One of them is called alpha particle based spectrometer. So we send alpha particles to the surface. It will ablate materials, produce gas. And this gas is, you do spectroscopy on this gas and you can find the elements in it. Hydrogen, carbon, silicon, oxygen, what is there in it. There is another instrument where you will send a laser beam into the laser. And this will also fuse the material, produce gas. We do the same thing. This was there on the rover in the Pragyan Yor. Pragyan Yor was only 30 kilogram. And these instruments are just 3 kilogram, 2 kilogram mass. So how to make a spectroscopic instrument in just 2 kilogram? That is a trick. When you do missions there, you cannot make a 10 kilogram spectrometer. You have to compact it and make it in very small size. There was another instrument to measure the moon quakes, the earthquake like the moon quake. So we had an instrument which was brought in a cable down and put on the surface of the moon and it measured the moon quakes. And another instrument is called MENCA, which has a probe. With this probe will measure electron density on the surface. The moon doesn't have atmosphere, but it has an atmosphere of electrons and charged particles. So night and day, this will move up and down. So we were measuring that. And we had another instrument, which is a drill, which will go to the surface and then measure the conductivity of the regolith to find out how the heat is absorbed from the sun, how it keeps underneath. And we have a lot of new findings on it. Okay. So these are some of the information. Okay.
Means I was saying that I have heard some people saying that when we launch a rocket like Chandrayaan 3, some people fire this means fire water on the when it was launching. I was heard that, but why they do like this?
Do one thing, you have to come to Sriharikota. Okay, where is the Sriharikota launching station?
Andhra Pradesh.
Andhra Pradesh is near Chennai. I will show you the water jet that we have built. It's a massive water jet facility. So we also send water. It's not heard. We are actually doing it. So when the rocket is taking off, we inject water into the jet plume and huge amount of water. I don't know, 600 meter cube or something. It is emptied in just 10 seconds. Because this water, what it does is there is so much of sound you produce, no rocket?
Yes.
And this water comes and this water can reduce the sound substantially.
Oh.
And the sound, unless you reduce, there will be a lot of vibration on the rocket and electronics will fail. So you need to put this water into the plume to reduce the sound.
And I was saying that when the rocket goes out of the earth, where it orbits the earth many times, why not directly goes to the moon or other planets?
It is because of a secret, because the rocket doesn't have enough energy to send directly to the moon. So what you do is you put in an orbit around Earth and every satellite has got also a rocket inside. Okay. inside the satellite there is an engine, and we fire that engine. And when you fire anywhere, it is not good. We fire only at when it is very close to the earth. At that time, the firing is more efficient. When it is away from earth, if you fire, it is not efficient. So we use every time it goes and come back and come to earth, we fire. Then it will go further. Then again, it will go and come back to earth and we fire. It will further go. So like that, 3-4 times you fire, it will go to moon. So with less energy, you can go to moon. This is the trick our Indians have found out. That's our jugaad.
But
Thank you.
But does that not happen when other guys are launching it and they do it straight away to moon?
No, the moon missions, what Americans did was straight to moon, because the rocket was so powerful. And there is also a reason, when human beings are inside, you cannot do this.
Of course.
Because you
Time lag.
need to reach them very fast. And this took almost 30-40 days. And we cannot spend human beings in around Earth for 30-40 days. It could be done for Chandrayaan 1, 2, 3 and all that, but not for human space flight.
But it is efficient from the point of view of cost.
It is efficient from the cost and mass, but not efficient from the time. Okay.
Of course, time it takes more. Yeah, we'll take few more as I'm
to
just
check
told
with
that
your timing availability.
Now,
Okay.
we just told that we have some more time. We'll compensate for the time which was the delay. Yes, please.
Sir, my name is Hari, but can you brief us how satellites work?
Okay, I will come to your level. See what all things you have. What all things you have? Ask your sensors. What are your sensors? You tell me. Eyes, ears, mouth, smell, skin,
Yes.
Panchendriya, no?
Yes.
You have 5 sensors. So essentially satellites also got sensors. It will have sensors of various kinds. It has something called accelerometers. It has rate gyros. It has cameras. It has sun sensors. It has earth sensors. So it will sense earth. So when satellites are injected in orbit, it will rotate around earth. Like moon, no? Moon is rotating around earth. You don't have to put energy, every time. It is always rotating. So once you give O to orbit and give a velocity, it will always rotate around earth. But to make it work, you need to have these sensors. It has to know where it is. For that, these sensors are used. It look at earth and find out now it is earth. It look at sun and find out. It can look at stars and say, I am in this direction, in this position. So using star sensors are there. I can locate its position with respect to the universe, because stars gives you a position. Then it can do so many functions. It can take photo of earth, like using camera, and you can do continuously take image and take the data and send it to earth through antenna. There will be antennas on satellite. It will beam the data, and earth has another antenna will receive the data. And we can send a command to the satellite. We'll send, now turn to the right, it will immediately turn. Okay, it has some actuators. It will turn the satellite left to right. It also has solar panels producing, you've seen rooftop solar panels? Like that, it has huge panels. It will produce 5 kilowatt, 10 kilowatt of power. Okay, it also has liquid engines to do motion, turning, writing, orbit changing, etc., etc. So so many items put together, satellites are working. Okay.
Maybe a connected question, and my level is the same when you said that his level. Maybe. So pardon me for my ignorance, but there's lot of debris would be there in the orbits, right? And this 5,000 satellites, one company is launching and so many more come. What happens to that debris? And there would be some mishaps, accidents also.
Yeah, there are mishaps. There are mishaps. Today, there are 20,000 satellites working and not working. And there are 1 lakh big debris. Big debris means anything about 10 centimeter in size, almost 1 lakh. Everything below 10 centimeter, almost 5 lakh pieces are there. So it's a huge debris are there. But fortunately, the space is so vast. The distance between them is so huge that they don't collide. And if they are colliding, then we need to move them. So we do an observation from ground. And this network is available in various places. The primary information for this comes from US. During Star Wars time, they created a ground network to observe all the satellites, and they observe every object bigger than 10 centimeter in size, and it is cataloged. And every day you can get an information of the position of this object and its trajectory. And we get this data and we use in a computer simulation and then find out how things are going to move. And we predict for next one day where they will be. And if there is a possibility of collision, etc., we want the satellite operators to move here and there a little bit, or launching here and there a little bit. Changes are done. So this is a continuous activity.
Typically, but it remains in the same orbit, or it moves
No,
orbits also?
we need to move them. We need to move.
But does it change the orbit drastically, hundreds of
Sometimes,
kilometers?
sometimes we change drastically. For example, if you have to deorbit, we change drastically. You have to send something called graveyard orbits. Geostation orbits, satellites are sent to graveyard orbits. In such cases, we move drastically. Such things are done. So I don't go into too much of technical things at this. Yeah, it's okay. I think we need to close now. I think the time, no, time is up. I think we need to close.
I think so. We can close. Over to.
Good evening, friends. I'll just take 2-3 minutes. It's an absolute honor to be part of this today's celebration, momentous occasion of the Management Day, National Management Day today. And today's discussion, the topic, India tomorrow, unlocking innovation, industry, and talent, has been very thought-provoking and inspiring for all of us. On behalf of AMA, I extend my heartfelt gratitude to Dr. S. Somanath, former chairman of ISRO, for sharing his deep insights into India's space advancements and innovation-driven future. His vision and leadership continue to propel our nation towards new frontiers, and we are privileged to have the opportunity to learn from him today and from the wonderful interaction and the questions, especially from the young audience. I'm a little nostalgic today, remembering September 23, when, AMA received the Best Management Association Award at the hands of Shri Dr. S. Somanath in IMA. That was in 23. And, as we saw in the discussions, besides the innovation in space research, we have many management lessons learned from ISRO. The way they do their projects, their missions, the way they plan them, execute them, so economically. So they are great management lessons. And thank you, Dr. S. Somanath and Team ISRO, for elevating Indian space research to global standards and placing India among the world's leading space-faring nations. A big round of applause for Dr. Somanath and And also, we are thankful to Mr. Chiranjeev Patel, who is the member of our executive committee, to bring Dr. Somanath here. And a special thanks to Dr. Savan Goriawala, President AMA, for moderating this engaging conversation, enriching the discussion with his valuable perspectives. And finally, my thanks to the members of the press and the media, invited guests, dignitaries, attendees, for joining us this evening and making this event a resounding success. We look forward to many such kind of discussions. Thank you, friends.
Thank you. Yes. Yeah. So many times you would have heard. Yes. I was hearing of when you talked about Dr. Sarabhai. My grandfather. Yeah.